Hey guys, lesson 56 is more integration by guessing / a word of caution. The key is here, it's, kind of, shall I say phase 2 of integration by guessing. When we did integration by guessing back in December, everything magically worked out perfectly, didn't it? Okay, we would, guess something, and once we applied chain rule and everything, all the pieces were always accounted for. And the ones we're going to look at today, not everything's going to be accounted for. We might have some extras or some missing pieces, and that's what we're going to look at is, okay, what happens? How do we compensate for those extra or missing pieces? So, looking at example 1, we are being asked to integrate the integral of sine of 3t dt. So it's integration by guessing. If you had to guess, what's the integral of sine of something? Negative cosine of something, right? And this is where my brain does, okay, the derivative of cosine is negative sine, so the derivative of negative cosine is positive sine. So, our guess then, so to speak, is, since this is the integral of sine of 3t, our guess is the negative cosine of 3t. Okay, keeping those insides the same. So what I'm going to do over here is I'm going to use u equals negative cosine of 3t. And what this is this is my guess. Like if I had to guess what the answer to this problem is right now, I would say, okay, the integral of sine of 3t is negative cosine of 3t. Now, how do we check that? In order to check that, we take the derivative. And that's what we're going to do to figure out our missing pieces here. When I talk about the derivative of u, we're going to do this using differentials. So the derivative of u, I'm just going to say is du. What's the derivative of negative cosine of 3t? Okay. Sine of 3t. Then what? We have to employ that chain rule, right? If the derivative of negative cosine of something is sine of something, then times the derivative of something. So times the derivative of 3t, which is 3. And then because we took this with respect to t, we're going to say times dt. Now, the question is, does our guess match up with the original problem? So notice, in the original problem, we have a sine 3t. In the response to my guess, I have a sine 3t. In my original problem, I have a dt. In the response to my guess, I have a dt. What doesn't pair up? The 3. How do you compensate for a factor of 3 so that when I give my guess here, it will work out when I actually integrate? Okay, divide everything by 3. So what I tend to say is, okay, a 3 I'll compensate by putting a 1/3 out front. Or in other words, dividing by 3. So if my guess was negative cosine of 3t, I take that guess and multiply it by 1/3, and that's my final answer. Does that make sense? So the integral of sine of 3t dt, well, I was almost right. I said negative cosine of 3t, but then we multiply it by 1/3. So it's negative 1/3 cosine of 3t. And because we're doing integrals, we say plus c. First homework back from Christmas, good chance you guys forgot your plus C's. Maybe not, but. And can you check yourself here, guys? I mean, the idea here is I can work backwards. The integral, the derivative of cosine of 3t, or I should say the derivative of negative cosine of 3t, is going to be sine of 3t times 3, which is going to cancel out with that 1/3, and then I'm at sine of 3t. Okay? That's the twist today, is you have to watch out for what pieces do not match up that I need to compensate for. Questions? Okay. Let me know if you have questions as we go. Otherwise, I'm going to keep on moving. Example 2. We are integrating x squared times 3x cubed plus 4 to the 4th dx. I need a guess here. And on all of these today, unless we have u's in the problem, I don't think we ever do, I'm always going to say u equals. What does it look like the main part of this problem is?
3x cubed plus 4 to the 4th.
Okay, the idea of those parentheses raised to the 4th. What is the integral of some parentheses raised to the 4th?
4 to the 5th, something raised to the 5th.
Okay, and you're seeing where we're going with this. I'm not going to use the 1/5 right now. Okay, and I guess you could, just not how my brain. I see where you're going, and you see where I'm going, so we'll meet in the end. But the idea of what I tend to think is, okay, this is something raised to the 4th, so my guess is going to be something raised to the 5th. So 3x cubed plus 4 raised to the 5th. In all honesty, I haven't thought that way before, but you could go ahead and put the 1/5 out there. I don't know. I tend to just put on later. Maybe that's how the book teaches it. Maybe that's just how my brain works. But again, you guys will get to the point where you won't necessarily write all this down. You'll see it and be able to work with it. So, okay. So, let's check this and see what missing pieces we need to compensate for. So, the derivative of something raised to the 5th becomes what? 5 out front, right? So 5 times your something, 3x cubed, plus 4 raised to the power of 4, because you subtract 1. And then what? Times the derivative of the inside. What's the derivative of 3x cubed plus 4? 9x squared, plus 0 if you want, and then times dx. Okay. 3x cubed plus 4 to the 4th is already here, yes? What are my other pieces?
X squared.
X squared. Is x squared there? It is. And?
Dx.
Officially dx. What do I have to compensate for? The 5 and the 9, which is 45. Yep. And I don't have them together, but we're talking the same language. How do you compensate for a 5? That's the 1/5, which you could have already had out front. Maybe you don't have to compensate for that. How do you compensate for a 9? 1/9. So individually, I'm thinking 1/5 and 1/9. How do I compensate? How do I put those together then? 1 over 45. So based on the way I did this, my original guess was 3x cubed plus 4 raised to the 5th. I'm going to use that guess and put what out front? 1/45, or 1/5 times 1/9. So I'm going to say 1/45 times my guess of 3x cubed plus 4 raised to the quantity of 5, and plus c. Obviously, you may find ways to think about this slightly different and on your own, but as long as you're getting there, that's what matters. Questions? Okay. Example 3, we're integrating x squared dx over the square root of x cubed plus 1. What should you think about before you start working the problem here? I would rewrite it. Because we don't think in terms of integrating square roots, we think in terms of integrating powers. So this is the integral of x squared times x cubed plus 1 raised to what power? Negative 1/2 dx. So that's just kind of rewriting the initial problem to get yourself going. Okay? Do you have a guess in mind?
Two times x cubed plus 1 to the 1/2.
What did you say?
2 times the parentheses raised to the 1/2.
You guys want me to do this differently today, don't you? Okay, so he's saying 2 times x cubed plus 1 to the 1/2. My brain just tends to think x cubed plus 1 to the 1/2, and I get the 2 later. Okay, both ways work. I don't know if I can change like that on the. I have to rethink how I write all that down. It would work.
Like if you have if you're integrating x to the 4th, then you if you're just doing that,
Right.
then probably you already add in. If you notice that it's canceled out, you already
Yeah.
do that first.
It makes me wonder if I should be teaching it that way instead. I mean, I totally see what you guys are going for here. Why? And I'm only wondering if the book teaches it this way. And maybe that's where, I've gone. I don't know. So, okay. So one way or the other. I mean, overall, the key you have to catch is what's the integral of something to the negative 1/2? Add 1 to the power, and you have to think positive 1/2, right? Whether you go ahead and put the 2 out front now or you do it later is up to you. So I'm going to use the x cubed plus 1 to the positive 1/2. And then when I take my derivatives, derivative of u is du. Derivative of something raised to the 1/2. One half times my something. Subtract 1, so 1/2 minus 1 is negative 1/2 times derivative of x cubed plus 1 is 3x squared, and then times dx. So as I look at my matching pieces, x cubed plus 1 to the negative 1/2 matches, right? My x squared and my dx match. My leftover pieces I have to accommodate for are 1/2 and 3. Some of you only have to accommodate for the 3, right? How do we accommodate for a 1/2? You need a whole number of 2 out front, yes? In other words, basically the reciprocal, right? How do we accommodate for a 3? A 1/3. So, I'm using my original guess of x cubed plus 1 to the 1/2, multiplying it by 2 and by 1/3. What is 2 times 1/3? 2/3. X cubed plus 1 to the 1/2. Anybody? Plus C.
That's the problem with those problems. By the time you finish all the steps, you forget that you were solving an integral to begin with, because you've gone back and forth enough times.
It's easy to forget the plus C when, yes, we had to stop and do other things along the way. I get it. And that's where it's always good to go back and say, okay, what was the question being asked? Oh, it was an integral. Oh, I need a plus C. Okay. Example 4, integral of cosine cubed 2t sine 2t dt. Thoughts on what the main piece is here? Cosine cubed. Okay. And you realize that sine is going to be part of the chain rule then. Okay, so always go with whatever has your power there. So that means for my guess, I know you guys are going to give me a couple different options here. What's the integral of cosine cubed? I'm going to say cosine to the 4th. I don't know. Should I go the 1/4 cosine to the 4th? I have mixed emotions about that. Only because it forces me to change. I think that's the only reason I have mixed emotions about it. I do like it. I really do. Okay, so somehow or another, whether you incorporate the 1/4 now or later, it's cosine to the 4th of 2t. That's my guess. Okay, take your derivatives and think about what needs to compensate. Derivative of cosine to the 4th. It's a power rule, right? 4 cosine to the 3rd of 2t. So the derivative of something to the 4th is 4 something to the 3rd times the derivative of something. So what am I doing the derivative of? Not just 2t. It was something to the 4th, and the something was the cosine 2t. You know what? Maybe it might have been better. I think about this after the fact. Where's my whiteout? What I probably should have done here is forced you guys to think like this. Cosine 2t to the 4th. Because if you do cosine 2t to the 4th, you can more clearly see the insides is not just the 2t, but cosine of 2t. So if you see it coming, there's a double chain rule here. So derivative of something to the 4th, 4 something to the 3rd, times the derivative of something. What's the derivative of cosine of 2t? Or let me rephrase that, what's the derivative of cosine of something? Negative sine of something. So negative sine of 2t times the derivative of the new something. So what's the derivative of 2t? 2. And then dt. Okay. What matches? Cosine 2t cubed matches. Sine 2t and dt. What am I compensating for?
4, 2, and -1.
A 4, 2, and a negative, or -1. So compensates for a 4, if you didn't already put it out front, is a 1/4. What compensates for a 2? A 1/2. And what compensates for a negative? Another negative.
C2 almost be making right.
Okay, so what am I putting out front of my guess here? -1/8. And if you already had the 1/4 as part of your guess, then you're just multiplying the 1/4 by -1/2. So -1/8, what was my guess? Cosine 2t to the 4th. So I'm going to say cosine to the 4th of 2t. Yep, what was the original problem? An integral, so plus c. Okay. Integral of 4 secant squared 3t dt. What's your thoughts?
So it's secant to the 4th or something.
Did you say secant to the 4th?
Yeah.
Disagree.
It looked like a 3 from where I'm sitting.
What?
It looked like a 3 from back here.
Oh, the power?
Yeah.
Well, the power is a secant squared.
That makes it
So something to the third is the natural guess. Except, this is a special case. What is secant squared the derivative of? This is a rough one. Coming back after Christmas break, you haven't worked with these derivatives as much lately. Secant squared is the derivative of tangent. So special case. So all these other times we've just been upping it a power, right? Oh, the integral of secant squared has to be secant cubed. Except secant squared is a special case we have to recognize. So the integral of secant squared is going to be tangent because the derivative of tangent is secant squared. Are you tracking with me here? Whether you want to be or not. So our guess, the integral of secant squared of 3t is going to be okay, so I wrote, and we can do that again. There's multiple different options. Here's the deal. You can't forget that 4, yes? So you can take the 4 with the guess, or the other option is, and that might actually be better, what I tend to think is, okay, that 4 is a constant, right? So that 4 just can go in front of the integral, meaning the 4 has to just carry on down straight to my answer. Okay, or I agree, you can think 4 tangent 3t. That would work as well. Okay. Double check your guess here. The derivative of u is du. Whoops. What's the derivative of tangent of something? Secant squared of something. So secant squared of 3t times the derivative of something. So the derivative of 3t is 3 times dt. Okay, check it all out. Secant squared of 3t and dt. Secant squared of 3t, dt. It's all there. We also have a 3 to compensate for. How are we compensating for the 3?
4/3.
The 3 itself is a 1/3. So we have to put the 1/3 with our guess of tangent 3t and the 4 that I'd carried out front. Or, again, I like the idea of making my guess for tangent 3t and multiplying by 1/3. So 4 times 1/3 is going to make this 4/3 tangent of 3t. And plus c, because we were doing an integral, if you recall. And our final fun one to finish up. The integral of e to the square root of x dx divided by square root of x. What do we know about the square root of x's? Instead of e to the square root of x, I'm going to say e to the, not square root of x, but x to the 1/2. That square root of x in the denominator, bring it to the numerator, and it's just then x to the negative 1/2 dx. So that's me personally, how I rewrite this problem to get myself going. Bless you.
I'm allergic to overly complicated problems.
This isn't that bad. Okay. What's the main thing here? What's the main part of this problem? E to some power. What's the integral or derivative of e to some power? E to some power. So what's my guess? E to the x to the 1/2. You guys call this an overly complicated problem, but only because there's an exponent within an exponent. But that doesn't make it as horrible as you think, because the base is e. If the base was something else, I might agree with you, but the base is e. Okay, so the derivative of e to some power is e to some power times the derivative of some power. What's the derivative of x to the 1/2? 1/2 x to the negative 1/2 times dx. So what matches? E to the x to the 1/2 matches, x to the negative 1/2 matches, and dx matches. What doesn't match? The 1/2. How do I compensate for a 1/2? You multiply by a reciprocal of 2. Final answer? Two e to the x to the 1/2 plus c. Or if you want, you could say 2e to the square root of x plus c. That's one of the things I'm fine with either or. Obviously know that they are equivalent. Okay, guys. So that was kind of the extension of integration by guessing. I mean, the good news is the parts that don't work out are just different by a constant. So it's just doing the compensation, multiplying by the reciprocal there.